Okay, let's continue our probability conversation here with our die and see some other combinations and things that can happen with our outcomes. Number 5, find the most likely sum if you add the faces of two dice with the following number of faces. So in this case, we are adding two six-sided dice. So we set this up the other day. We said that means we'd have 1 through 6, and we would cross those with 1 through 6. And so we would add them up in our chart and get something like this. Our sample space would be 2 through 12 because we have all the numbers 2 through 12. But remember, there are 36 outcomes in this box. There's 36 outcomes that we have to choose from. Okay? Now, the most likely sum, if you look at the number that occurs most often, that is the 7. Anything that we have across this middle diagonal is the most common result. So 7, 7, 7, 7, 7, 7. 1, 2, 3, 4, 5, 6. This answer is a 7. Okay, that's the most likely. And the probability of getting a 7 would be 6 out of 36 choices. Okay? All right, so you can see what's going to happen here with a 2 8-sided die. If you set this up, okay, the number on the diagonal would be a 9. You would find out that you're 8 and let's see, 8 and 1, 7 and 2, 3 and 6. This would end up being your most common result. So 2 8-sided die means that your most common result would be a 9. All right, if you're thinking ahead, you should know the answer here. If you have 2 12-sided die, this answer would be a 13. Well, we're not done yet. Okay, if you had 100 equally likely faces on a die, well, then 101 would be the most likely sum that you would get in your sample space. Okay? All right, let's look at number 7. A candy machine gives out Reese's Pieces. The percentage of orange pieces in the machine is typically 40%. Let's get this one again. Okay, so orange pieces, typically 40% in the Reese's Pieces machine. Each time the candy machine is turned, approximately 30 pieces are dispensed. So when you crank it out and you dump in your hand, you get about 30 pieces. Now, 100 people used this machine in a day, and the number of orange pieces in the 30 that they received were recorded. So if we look at our results here, we have a situation that we are counting the number of orange pieces, and this would be the number of, what is that not going? People. Okay, so this is how many people got 10. So there was 1, 2, 3, 4, 5 people ended up with 10 oranges in their hand. Okay, that's what that's measuring here. There's lots of numbers going on here. Now, where does the 100 come in? Well, there should be 100 dots on here. If you added them all up, that would be all the 100 people. Which number of orange out of 30 is the most common? Well, clearly that is 13. 13 happened the most. That would be the mode. Estimate the probability of getting 11 to 14 orange pieces in a group of 30 pieces. Now, this would be experimental probability because we're not saying theoretically, we're basing it on exactly what happened. So we're only looking at our results. 11 to 14. So that would be here. So if we looked at all those tall ones and we counted them up, there should be 59. So that would be 59 out of 100 results got 11 to 14. Okay, so that would be 59%. All right, let's look at this one on the bottom. To the right is the distribution of the number of orange in 30 pieces after 30,000 people have turned the handle. How many oranges should you expect to get in your 30 pieces if you go to this machine? So based on the experimental probability, we're saying, what would you expect if you went there? Well, this is what we did at the beginning of the year. You looked at it and you said, where's my most likely result? And that really would probably fall in there, that we would expect um, 11, where are we at here? 11 to 13 orange pieces. That is the most typical result, and that's what we would probably predict most likely that would happen. Now, could you end up with, let's see, the lowest here was maybe like 4. Yeah, that could certainly happen, but that is not typical because 11 to 13 is the most likely to result. Okay, all right. Use this for your other example.